Worksheet number 8, the reaction process. Here questions 1 to 3 refer to the following diagram. Here you have energy diagram. So question number 1, which letter corresponds to the activation energy of the reaction of forward reaction? So the question asks about activation energy for forward reaction. So if you remember from the energy diagram, this is the activation energy here, the energy difference between the reactant and the activated complex, or here from the reactant and activated complex. So here activation energy, the energy difference between reactant and activated complex, which is letter A. So the answer is A. Now question 2, which letter corresponds to the change in energy for the overall reaction? Overall reactions, here from the energy diagram, the energy of the overall reactions means that energy difference between reactants and products, delta H. Or here, energy difference between reactant and products, delta H. So here in this diagram, C represent the energy difference between reactant and product. So the correct answer is C. Now question 3, which letter corresponds to the activation energy for the backward reaction? So here the activation energy for the backward reaction, the energy difference between product and the activated complex, between product and the activated complex. So here the question, the energy difference between products and the activated complex is B. So the correct answer is B. Question number 4, factors that influence whether or not two colliding molecules will react include which of the following? So if you remember the assumptions of collision theory, for particles to react, they must collide in correct orientation, and they must have sufficient energy. So here the energy of the collision, yes. The orientation of the molecules, yes. The entropy of the particles, no. 3 assumptions: collision, orientation, and they must have enough energy. So the correct answer is 1 and 2, C. Now question 5. Which point on the diagram represents the point at which the transition state exists? Transition state exists, it means activated complex, or it means intermediate. So the correct answer is B. Here if you remember from the energy diagram, here the activated complex at the top or here. If you have reactants and products, here the activated complex. So the correct answer is B. Now, question 6. The minimum amount of energy needed to start a reaction is called. Here, the minimum energy needed for a chemical reaction to occur is called activation energy. So, it's called activation energy. So, the correct answer is A. Now 7. Two molecules can't react if there is not enough kinetic energy, pressure, time, volume, none of the above. They must have enough energy for a reaction to occur. So the correct answer is A. From assumption number 3, here particles must have sufficient energy to break the bonds and form a new bonds. So, for a reaction to occur, there must be an enough kinetic energy. Question 8. Given that a reaction absorbs energy and has an activation energy of 50 kilojoule per mole, which of the following statements are correct? Okay, here the reaction absorbs. Absorbs means it's an endothermic reaction. And in endothermic reactions, the reactant, the energy of reactant less than the energy of product. Here, the energy diagram for endothermic reaction. Here the reactants and here products. Now, and has an activation energy of 50. Activation energy is the energy difference between reactants and the activated complex. So, an activation energy of 50. Here, 50 kilojoule. Which of the following statements are correct? Now, the reverse reaction has an activation energy equal to 50. The reverse reaction has an activation energy less than 50. The reverse reaction has an activation energy greater than 50. And delta H of the reaction is less than 0 and delta H of the reaction greater than 0. For endothermic reaction, delta H greater than 0. So here, this is the correct answer. Now what about the activation energy for the reverse reaction? Activation energy of the reverse reaction, here is the energy difference product to the activated complex, which is less than 50. So here, the reverse reaction has an activation energy less than 50. So this is also the correct answer. So the correct answers are 2 and 5. Here 2 and 5, D. Now question 9. A reaction mechanism shows here chemical equations indicate only which substances disappear and which substances are produced, and they don't show the mechanism. Mechanism means what? The step-by-step sequence or reactions. So here, mechanism, only one step along the reaction pathway, the inter-stepwise set of chemical reactions including the intermediates along the pathway, yes. Here, no, not one step. Only the final balanced equation, no. Only the rate determining step for a reaction, no. The correct answer is B. Question 10. In an energy diagram, the activated complex is represented at the. Here, the activated complex at the top of the energy diagram. So here, left end of the curve, right end of the curve, bottom of the curve, top of the curve, yes. So the correct answer is D. Now question 11. To react, gas particles must collide, yes. Be in the same physical state, have the same energy, have different energies. No. They must collide. This is one of the assumptions of collision theory. The assumptions are particles must collide and they must collide in correct orientation and they must have enough energy. So the correct answer is A. An effective collision has sufficient energy, yes. A favorable orientation, yes. So here, sufficient energy and favorable orientation, yes. A reaction mechanism, no. So the correct answer is C. An effective collision must have sufficient energy and favorable orientation. Now question 13. How does the the energy of the activated complex compare with the energies of reactant and product? Here, the energy of the activated complex, it's at the top here of the energy diagram or energy curve. So the energy of the activated complex greater than the energy of reactants and greater than the energy of product. So here, it's lower than the energy of both reactants and product. No. It's lower than the energy of reactants but higher than the energy of a product. It's higher than the energy of reactants but lower than the energy of products. No, it's higher than the energy of both reactants and product. So the correct answer is D. Now question 14. The step-by-step sequence of reaction by which the overall chemical change occurs is known as, so here, if you remember from the handout, mechanism of reaction, step-by-step sequence of reaction. So step-by-step sequence of reactions, it's called the reaction mechanism. So the correct answer is C. Now questions 15 to 17 refer to the following diagram. You have to get or to find delta E, the energy difference between reactants and products, EA, which is mean activation energy, the energy difference between reactants and activated complex, and EA dash, which is mean the activation energy for the backward reaction. It's the energy difference between products and activated complex. So here you have the energy diagram. Here the reactant, and here product, and here activated complex. So Delta E is the energy difference between product and reactant. So to get the difference here, this is delta E, which is equal 40 minus 20, which is equal 20 kilojoule. Now EA, the activation energy for the forward reaction, it's the energy difference between reactant and the activated complex. This is EA, which is equal 100 minus 40. 100 minus 40, which is equal 60 kilojoule. Now, the last one, activation energy for the backward reaction. It's the energy difference between a product and the activated complex. Which is equal 100 minus 20. This is an activation energy for the backward reaction. So 100 minus 20, which is equal 80 kilojoule.